All right, now I'm going to try the second practice problem from chapter 9, section F. This one starts off with a negation of an existential. So it says it is not the case that there exists an x such that mx and there exists a y such that, sorry, put that in parentheses, there exists a y such that my and gxy, close parentheses, close bracket. And then I'm supposed to prove, and now I need to pan over because that's long. So for all x, if mx, then for all y, if my, then not gxy. Close parentheses, close bracket. Okay, that's a very long one. Let me just show you that again. So it says, for all x, if mx, then for all y, if my, then not gxy. Okay, this one is long, and it's honestly kind of ugly. So how are we going to approach this? Here's what I'm thinking. I'm noticing a few things here. One, really importantly, I look at my mx here, I look at my my, my gxy, and I'm seeing those all line up with what I'm seeing over here. There's an mx, there's an my, there's a gxy. That gets me to thinking that I'm going to be using some replacement rules. Everything's kind of in order. It's just that these are conjunctions and these are conditional. So if I can somehow convert conjunctions into conditionals, that would get it done, I think. Now I'm going to run some problems. First thing, of course, I don't really have a rule for converting a conjunction into a conditional. I can convert a disjunction into a conditional. That's implication allows me to go back and forth between conjunctions and, between disjunctions and conditionals. But I also have a rule that converts conjunctions into disjunctions. That's De Morgan's. So I can probably combine those ideas, right? Take these conjunctions, use De Morgan's on them, and then use implication on those disjunctions to get to my conditionals. Okay, I know that's a lot, but that's what I'm thinking right now. Just got to be familiar with how you're going to get, how those rules work. So how can I possibly get from conjunctions to conditionals? Well, I'm not going to do it directly, but if I think it through, I can see that I can get there in a couple of steps. So what else am I going to run into here? Well, I'm noticing already this is a universal statement, right? This is not. This is I see existentials, right? Right? I see universal and universal. So that tells me I'm probably going to use a change of quantifier. Right? Change of quantifier will get me from an existential to a universal or vice versa. So I'm thinking, okay, I'm going to need to use change of quantifier here. This looks well set up for it, right? There's not an x such that this is true, so for all x this is not true. So I'm thinking now what I might want to do is I might want to use change of quantifier to convert these existential statements into universal statements. I'm also thinking that if I'm going to get to a statement about all x's, this universal statement about all x's, I'm thinking I'm going to need to, when I convert this, I'm going to get a universal statement, right? I'm just going to say that for all x, it's not the case that such and such. I'm thinking that I'm probably going to want, it's probably handy to instantiate the universal quantifier statement into a statement about a free variable with x as my free variable, so I can use a universal generalization later on to get back to this for all x right here. I'm not so sure that there's any other smooth way of doing that. Let me show you how that's actually. I'm going to combine all those ideas and just show you how that works out. Hopefully this will go smoothly enough for me. So, and just to be clear, when I'm looking at a problem like this, even I can be a bit terrified. It's not at all obvious how it's going to work. I just have to play around sometimes, but I think that this is going to work. I'm going to go ahead and just start with that change of quantifier. Right, so I'm going to start out with, for all x, it is not the case that mx and there exists a y such that my and gxy bracket. And that's just from line 1 by change of quantifier. Right. I wanted to go ahead and just get to that universal statement. Now I can drop off that universal and just work with the free variable x. Make everything a little easier for me here. Just get rid of that thing. Say it's not the case that mx and there exists a y such that my and gxy. Okay, and then I need a bracket there. Now in this case, you can instantiate a universal to a constant, or you can instantiate to a free variable, and you can even use this same variable. I like to do that generally just to keep things simple. But when I use I know I want to use a free variable because I need to get back to a universal at the end, and I need a free variable to do that. Can't use a constant in that case. So this is going to come from line 2 from universal instantiation. Now things are looking pretty good because I see a negation of a disjunction, or of a conjunction, I'm sorry. Negation of a conjunction, and I know by De Morgan's I can get a disjunction from that, right? And that's what I want right now because I want to get to a disjunction so I can eventually get to a conditional. So I'm going to say it is not the case that mx, or it is not the case that there exists a y such that my and gxy. All right, that's just application of De Morgan's. Okay. Now, that worked out really well for me because I can already tell the implication is going to tell me either mx, or if mx, then whatever this stuff says. But I need to get a little more work done here first. As I know from the conclusion says for all y. This says it's not the case that there exists a y. That tells me again I probably want to use change a quantifier right there to convert this existential into a universal. So either it is not the case that mx, or for all y, it is not the case that my and gxy. Right? That's just a for change a quantifier. And that's looking pretty good as well because, again, I need to get from this conjunction to a disjunction. This looks like a perfect setup for using De Morgan's. All right? So I'm going to at this point say that it is not the case that mx, or for all y, right, either not my, I almost forgot my not there, not my, or not gxy, right, from line 5 by De Morgan's, right? And again, that's just, if the conjunction is false, then one of the conjuncts must be false, right? So if both aren't true, then one of these two things is false, at least. So now line 7, again, I want that disjunction there because now I can start using my implication rules. So not mx, or for all y, right, if my, then not gxy. Right? Basically, remember the rule is just implication, so 6 implication. And it makes sense if you think about it. This says that one of these two things must be false. This just says, well, if it's not the first one, then it's the second one, right? And then I can repeat that again because I had this junction out here, right? Again, so this tells me if mx is true, then for all y, right? If my, then it is not the case that gxy. And now I'm almost where I want to be, right? That's just line 7 implication again. I know this is a long one, but bear with me, we're almost there. So now I just need to, I have this free variable x, I need to have this universal statement here. So I will just introduce the universal quantifier for all x. I need a bracket so it covers all this stuff, right? If mx, it's a terrible m, but you know what I mean there. If mx, then for all y, right, if my, then not gxy, close, close, and that's from line 8 by universal generalization, and that's the big ugly conclusion I was looking for. All right, so that was a lot. I know that was a lot. So again, if you found this one challenging, there's no shame in that. This one is challenging. At least I think it's challenging. I honestly got a little lucky there. Things went as smooth as they did. I had a few ideas, and I just sort of saw the path as I was working it through. But I knew probably what I wanted to do. I knew I wanted to do the change of quantifier to get from these existentials to these universals, right? I was probably going to do it twice, as you can see, because I had two different universals I need to get to. I knew I was going to be using De Morgan's followed by implication, probably because I had to get from a conjunction to a conditional, so I had to convert the conjunctions to disjunctions and the disjunctions to conditionals, and that's all I really did. I introduced the free variable, and then at the end universalize or use the universal generalization to get back to a universal statement. That's it's a pretty familiar thing to do by this point. But there it is. That's the whole proof. I hope that made some sense. If you have any questions about it, don't hesitate to ask. It's hard for me to even get the whole proof in the frame here. So, all right. Hope that helps. Bye.